All right, in this video, we're going to be looking at augmented matrices and really get introduced to Gaussian elimination. So let's start off with an augmented matrix. So an augmented matrix of a system of linear equation uses the coefficients and constants of the equations written in standard form. So unlike the last video, here we're writing everything as one matrix, not separate matrices. So here we're going to go ahead and have 2, 7, 1, negative 25. So those constants become the fourth row here. And we're going to have 1, 5, negative 8, 81. Negative 1, 4, 3, and negative 18. This is our augmented matrix. So a system is in row echelon form or in triangular form when the last equation contains just one variable. Each equation above contains the variables below and an additional variable. And the leading coefficient of each equation is 1. Give the corresponding augmented matrix of row echelon system below. So notice here our very last variable is z. Our next equation has y and z, and then the very last one at the very top, or our very first equation if you want, has x, y, and z. The leading variables all have coefficient 1. So this augmented matrix in row echelon form would look like this. It's going to be 1, 2, negative 2, sorry, 5, negative 29, 0, 1, negative 6, and 26, 0, 0, 1, and negative 3. Now, one of the reasons they call this triangular form is if you look here, notice how we start creating a triangle of zeros here. And that's where the triangular form comes in, is that we're really trying to create a lower triangle form of zeros. So row echelon form is convenient because the remaining variables can be solved by back substitution. So if you think back to when we were solving all of our systems by hand prior to matrices, right? Once we found a variable, we went back, we substituted it in, and we substituted it in, etc. So if we use row echelon form here, we can get z is equal to negative 3, right? We take that negative 3, we plug it in here, we calculated our y. Once we know our z and our y, we can plug it in here and calculate our x. So it allows us to go back and do that back substitution. The following operations are called elementary row operations, and they produce equivalent systems and can be applied to any augmented matrix to transform it to a row echelon form. So the first thing we're going to do is we're going to interchange any two rows. We can multiply a row by a non-zero constant, and we can add a multiple of one row to another row. So in essence, right, this is where, if you think back to when we were manipulating the linear equations, right, we are manipulating them still, except we're doing that in the form of a matrix. We'll go through an example. The following process of solving a system of equations is known as the Gaussian elimination, and it's named after the German mathematician Carl Friedrich Gauss. So we're going to write the system as an augmented matrix. That's the first thing. And actually, let's see if we can work an example as we work through these steps. So step 1 is we're going to write it as an augmented matrix. So let's take this matrix. Call this step 1. We're going to write this as an augmented matrix. So notice I don't have an x, right? So I have a 0x, and then I'm going to have 1y and 4 and 12. And then I have 1, negative 1, 3, and 25. So that's our first step. Our second step is to transform the matrix into row echelon form using elementary row operations. So remember that row echelon form is going to give us that lower triangle, that triangle here. So we want those 3 zeros there. So if I take a look at this, notice how, actually let's keep it like this so we can see both instructions. Notice how that first that second equation here already has a 0 there, which is great because now let's leave that one there. That one's already getting closer. So what we really want to do is we want to make this and this a 0. So let's take a look at how we can do that. We're going to use some notation which is going to tell us how to indicate the rows. So the first thing that we want to do is we want to take row, for instance, row 3, and we're going to subtract row 1, and that's going to go towards row 3. So what that means is that row 1 stays the same, 1, 2, negative 9, negative 59. Row 2 is going to stay the same, 0, 1, 4, and 12. But now row 3 is going to subtract row 1. Okay, so if row 3 is subtracting row 1, so that means I'm doing 1 minus 1, that's going to be 0. Negative 1 minus 2, that's going to give me a negative 3. 3 minus 9, that's going to give me a positive 12. And 25 minus 59, that's going to give me a positive 84. Okay, so that was our second step. So now what we want to do is we want to take a look at this and say, all right, what do we do next? So we're not in that lower triangular form just yet. So we're going to go ahead and decide another operation to do. So let's take this matrix and we're going to perform, let's see, we want to get this 3 to turn into a 0. So why don't we take row 3 and we are going to add it to 3 times row 2 and we are going to transform row 3. So I'm taking row 2 since it's a 1, so if I multiply row 2 by a 3, then I know that those two are going to cancel out. So let's try that out. So what is that going to look like? So over here we're going to say, let me write out that command again. So that means that my row 1 is going to stay the same. My row 2 is going to stay the same. But now my row 3 is going to be 0, right? But now I'm going to take this negative 3 and I'm going to add to this 1 times 3, so that's going to be 0. Then I take this 12, so 12 plus 3 times 4. So 3 times 4 is 12, so 12 plus 12, that gives me 24. And lastly, I'm going to get 84 plus 3 times 12, which is 36. So 84 plus 36, that gives me 120. Okay, so notice how close we are. We have that lower triangle right here. Right, we were able to do that. So now what we need to do, though, is we want to move on from here and we want to make sure that we can turn this into a 1. Okay, so the way that we're going to do that is we're going to take 1/24 times row 3. 2, and so we're applying this transformation to row 3. So this tells me row 1 stays the same. Row 2 is going to stay the same. But now row 3 is going to look like 0, 0, 1. And then 120 divided by 24, that's going to give us 5. So now notice that I have this set of 1s here that are going down, and then my lower triangle. So I have all 1s and then I have 0s, so I'm good. That's exactly what I wanted for row echelon form. So now that I have this in row echelon form, right, what does this mean? How does this translate back? So the way that this translates back is that now I'm going to rewrite this entire matrix see if I can get rid of this line. Rewrite this entire matrix back with variables. So this would be x plus 2y minus 9z equals negative 59. And then I would have y plus 4z equals 12. And lastly, z equals 5. Well, so now I just have to back substitute, right? So if z equals 5, then I know that y equals, I'm going to know that y plus 4 times 5 equals 12. So therefore y plus 20 equals 12. And y is going to equal 12 minus 20, which is going to give me a negative 8. So now I have z and y. I'm going to go back and substitute for x. So I'm going to have x plus 2 times negative 8 minus 9 times 5 equals negative 59. This becomes x minus 16 minus 45 equals negative 59. So x minus 61 equals negative 59. So therefore x equals 2. So then the solution to the system would become 2, negative 8, and 5. All right. So that was somewhat of a long process, but take a moment and see if you can find an attempt number 2. So let's pause the video here. So let's take this slow because that was a lot to process in one example. So let's start off with the augmented matrix. Did you obtain this? So now let's go ahead, once we have our augmented matrix, start to begin to consider what elementary row operations we are going to do in order for us to get that lower triangular matrix. All right, I'm going to start off by taking row 2 minus row 1. So in doing that, we are going to take this row, and we're going to be subtracting it from the top one. And we are changing row 2, so that means we're going to start off our new matrix by writing 1, row 1 the same, and row 3 the same. Except now row 2 is going to change because I'm subtracting row 1. So 1 minus 1, that's going to give me 0. 1 minus negative 1, that's going to give me a 2. And then negative 2 minus 4 is going to give me a negative 6. And negative 14 minus 6 is going to give me a negative 20. So that's the first step. Remember, we were trying to get that lower triangular matrix there. So how would you think about doing this one? So because I want to make sure that I get a 1 here, I'm going to go ahead and take row 2. I'm going to write it right here. We're going to do half of row 2, and we're going to change row 2. So this action is being applied to row 2. So when I do that, I'm left with 1, negative 1, 4, 6. 1 doesn't change. 3 is not changing also right now. 5. And so then we have 0, 1, 3, and negative 10. But notice now I have 2 of those ones, so I really need to now start thinking about row 3 and how to get rid of those, that 1 and that 2. So go ahead and take a moment and think about how you would get rid of them. So the way I thought about at least getting rid of this one is taking row 3 and subtracting row 1. And we're going to affect that change on row 3. So notice row 1 is going to stay the same, not changing anything there. Row 2 is going to stay the same, again not changing anything there. And then when I subtract 1 minus 1, that's going to give me a 0. 2 minus 1, that's going to give minus negative 1, that's going to give me a positive 3. 5 minus 4 is going to give me a 1. 6 minus 6 is going to give me a 0. So we have this new matrix. So what I'd like to do now is get rid of this 3. Okay, I want to get rid of that 3, turn that into a 0, right, and then come back and deal with this one here. So because I want this to become a 0, what do you propose we do? What row operation would you do? So what I'm going to do is I'm going to take row 2, actually I'm going to take row 3, and I'm going to go ahead and subtract 3 times row 2. We're going to make that change on row 3. So row 1 stays the same. Row 2 stays the same. But now row 3 is going to be subtracting 3 times row 2. So 3 minus 3 times 1 is going to be 0. So I got that 0 there that I wanted. And now I'm going to have 1 minus row 2. So that means that I'm going to have 1. So this is going to be 1 minus 3 times 3. Actually, I think, did I drop a negative? I did drop a negative. Notice that's a negative. This should have been a negative. This should have been a negative. That's a negative. So we're going to end up with 10, positive 10. And now I have 0. So I'm going to have 0 minus 3 times R2, which is at 10. So negative and negative is a positive. So I'm going to end up with a positive 30. All right, so now what I want to do is I want to get rid of that 10. So this means that I'm going to come up here now. So we're going to take 1/10 of our key of row 3, and we're going to have that change be reflected on row 3. So now we are going to go ahead and row 1 will stay the same. Hopefully I'm copying all these numbers correctly. I believe that should be a negative. And then I'm going to have 0, 0, and then 1, 3. And now we have it in row echelon form. Yay! All right, let's go ahead and write this out as the equations. So this would mean that I would have x minus y plus 4 equals 4z equals 6, y plus 3z, minus 3z equals negative 10, z equals 3. So now that I have those 3 equations, we're going to go ahead and substitute in z equals 3. So I'm going to have y minus 3 times 3 equals negative 10. So therefore, y minus 9 equals negative 10. So y equals negative 1. I have z, I have y. I'm going to go ahead and plug that into the first one. So I'm going to have x minus negative 1 plus 4 times 3 equals 6. So this becomes x plus 13 equals 6. So therefore x must equal negative 7. So our equation is negative 7, negative 1, and 3. All right, so let's go ahead and have you try example 3 on your own. All right, so this is a solution that I have for number 3 on the example. All right, so you don't have to necessarily go and do the same row operations that I did. You should still get the same answer no matter how you decided to organize your your elementary operation. So multiple different ways to arrive at the answer. But you really want to, you're hoping to have x equals 1, y equals -6, and z equals -2. All right, try one more. I know that there's a couple more that I have in these notes that you can solve. I think we had a total of 6 examples. We'll try one more, and then I'll write out the solutions for the last 2 as well. All right, so upon completing this, I was able to do this in 1, 2, 3, 4, 5 steps. Were you as successful, or did you do more? Did you do less? The final solution, then we get -4, 9, 7 is the final solution. So check to see. Apologize if this is a little bit sloppy. Right. Check to see if your row operations are different. Are they similar? And then to see if you got the correct answer. All right, that's it. This is how we do row echelon form.